Welcome to 4K's Private Tuition. I'm your host, Sei Shungu. So in this particular video, we're going to be talking about electrolysis. So we need to know some basics concerning electrolysis. So what we do is we split compounds into their elements using electricity. So this is what we call electrolysis. So what you're supposed to understand is that for insoluble solids such as metal oxides, we need to melt them into liquid form in order for us to carry out electrolysis. And for those compounds that are soluble in water, then what we simply have to do is dissolve them in water, because in order for electrolysis to take place, we must have mobile ions. So we need to either melt insoluble oxides or dissolve those that are soluble. Okay, so you need to remember that. So examples of soluble solids would be copper sulfate, sodium chloride. Okay, so what do you need in order to carry out electrolysis? You need the following equipment. You need your electrodes, and you have two electrodes. You have the cathode, which is negatively charged, and the anode, which is positively charged. You need a power source in order for you to have these two electrodes, the cathode and anode. So you should also understand the ions that are present in your electrolyte, which is the liquid form of your compound. Remember, I said it can be molten or it can be dissolved. It can be in aqueous form. So that liquid, we call it the electrolyte. That liquid should be able to conduct electricity. So let's look here what ions we can have. For example, in the case of copper sulfate, you have the copper ions and the sulfate ions from the copper sulfate, and you also have H plus ions and OH minus ions from water. So this would be aqueous copper sulfate. So those are the ions that are present. You should remember that water will split into its constituent ions, H plus and OH minus ions, in these solutions. So there are some rules that you need to remember, because you're going to discharge only one ion at each electrode. So what are the rules? You should remember that at the cathode, we are going to have our positively charged metal ions being attracted to the cathode. You should remember that cut ions are attracted to the cathode. So we are going to have our metal ions going to the cathode. We are also going to have our hydrogen ions, because they are positively charged, so they are also going to go to the cathode. But you should remember that only one is going to be discharged. Only one of these is going to be preferred and discharged. So there's a term which is used to describe this that is called preferential discharge. So there's a rule here that says the ion of the least reactive element will be discharged. The ion of the least reactive element will be discharged. So you need to remember this for the cathode. So here we need the reactivity series. So this is one of the applications of the reactivity series. So if you look at those metals, if they are present, if we have any of those metals present together with hydrogen, then you can see that hydrogen is less reactive than potassium, sodium, lithium, calcium, magnesium, carbon, zinc, iron. Therefore, it means that hydrogen is going to be discharged every time it is in a mixture with any of those metal ions. You need to remember this, because it is less reactive than all of them. So we're going to have hydrogen being discharged. But if copper is present together with hydrogen, you can see that copper will be discharged instead of hydrogen, because copper is less reactive than hydrogen in the reactivity series. Okay, so let's move on to the anode, which is positively charged. So we're going to have our anions being attracted to the anode. These are negatively charged ions. For example, our bromine, our nitrate, our sulfate, those ions are going to be attracted to the anode. We also have our OH minus ions from the water, which are also going to go to the anode. But there's also a rule here. We need to discharge only one of these ions. So the rule is that if a halide is present, a halide is an ion of a group 7 element. If it is present, then it is the one that is going to be discharged. Every time you have a halide, just know that it's the halide that's going to be discharged. But if we do not have a halide on the list of anions, then it is the hydroxide, which is the second most preferred. So it is the hydroxide which is going to be discharged in case you do not have a halide. So you need to remember this. This is very important. And when it comes to nitrates, sulfates, these are usually not discharged at all. So let's look at specific examples. If you had copper sulfate, you're going to have copper 2 plus ions and sulfate ions. You're also going to have OH minus and H plus from water. So our copper and H plus ions are going to go to the cathode, our cations, and there the copper is going to be discharged. If you remember what we said on the reactivity series here, we have on the reactivity series here we have our copper below the hydrogen, so it is going to be discharged. If you go to the other side, which is our anode, we're going to have our hydroxide and our sulfate ions, and it is the hydroxide that is going to be preferred. There's no halide, so the hydroxide ions are going to be preferred there. And you're supposed to be familiar with the equations that represent the changes that are happening at the cathode and the anode. So at the anode, our hydroxide ions are going to be turned into water and oxygen gas. So there's an equation that represents that change, which is 4OH minus to give us 2 moles of water, 1 mole of oxygen, plus 4 electrons. You're supposed to memorize this equation. Okay, let's look at another example. Sodium chloride, aqueous. What would happen? So those are the ions that are there, H plus, Na plus, OH minus, and our Cl minus ions. So at the cathode, what's going to happen? We're going to have our sodium and our hydrogen, but you see that sodium is on top of hydrogen. So remember, the rule says the least reactive ion is going to be discharged. So hydrogen is going to be discharged at the cathode. It's going to gain electrons and take off as the neutral hydrogen gas. And at our anode, we said if a halide is present, it is the one that is preferred. So the halide will go there, lose electrons, and take off as the neutral chlorine gas. And you're supposed to write the equations for these changes. So I'm going to challenge you to create those half equations. If you were to do electrolysis of molten lead bromide, you were going to have your bromine ions going to the anode, the anions going to the anode, and you were going to they were going to be discharged as the neutral bromine atoms, which would combine to form bromine gas in a covalent bond, of course. So you were going to discharge bromine gas at the anode, and if we go to the cathode, we were going to have our cations going there, and they were going to gain electrons and be discharged as lead. So the lead will settle at the bottom of your electrolytic cell. So we need to remember that at the cathode, since our cations are gaining electrons, they are being reduced, whilst at the anode, our anions are losing electrons, and hence they are being oxidized. You need to remember the definitions of oxidation and reduction in terms of electrons gained or lost. We said there's an acronym, oil rig. You can watch my other video for that. So the half equations are as follows. For bromine, it's going to lose electrons. We're going to have 2 bromine atoms going there to lose 2 electrons, and they will combine in a covalent bond and take off as bromine gas. So that's oxidation, loss of electrons. And for the lead, we're going to gain electrons, and our lead is going to settle at the bottom as at the neutral lead metal. So I'll meet you in another video. Enjoy.